Hi, my name is Ron Shook, and today we're going to work with molecular model kits to get a look at the carbon cycle. I've got some ways to show you how to put some of these molecules together in an efficient way so that class time can be used to our best advantage. So pay attention. First, we're going to build 6 carbon dioxides. The black spheres represent carbon. They have 4 holes in them, thus they can bond 4 times. I get my black spheres all set up. I fill them with the longer springs. This will allow you to make your conversion to glucose a little bit easier down the road. Right now, we want to end up with 6 CO2s. So I have my reds, which represent oxygen. There are 2 holes per oxygen, allowing it to bond 2 times. We simply bend over the springs, and we'll end up with a CO2 molecule in our model that looks like this. All I'm going to do now is repeat that 5 more times until we have 6 carbon dioxide molecules. So now I have built 6 carbon dioxide molecules, each with 1 carbon and each with 2 oxygen atoms. Therefore, I have a total of 6 carbons and a total of 12 oxygen atoms. Now, to work on some H2O molecules. For that, I will need 6 oxygens and 12 hydrogens, and it's time to pull out the smaller springs. To make one H2O, I'll grab an oxygen, and we'll put in 2 springs. And now I need the 2 hydrogens, represented in this case by white spheres, with 1 hole so that they bond 1 time. I'll be back in a minute after I make 5 more of these water molecules. So now we have our 6 CO2 molecules and our 6 H2O molecules. And I'll begin writing a chemical equation. 6, my coefficient, CO2, the name of my molecule, subscript, plus 6H2O, and that's going to produce something. So we will work on the products of this photosynthesis equation in just a moment. So one of our products of photosynthesis will be glucose, a sugar, and I'm going to show you how to prepare for the 5 carbon and 1 carbon tail backbone of glucose. So let's take a look at our CO2 molecule. The way this will work, we will remove one of the oxygens, set that aside. We will leave the other oxygen on, but we're going to release it from one of its springs. And we are going to do that 5 more times with our other CO2 molecules. One of the reasons I'm leaving this oxygen on is experiment has shown that the source of oxygen in glucose is the carbon dioxide. So here you see 6 carbon dioxides. They have lost one of their oxygens. I've left all the springs in. We're going to change that in a moment. But we are now ready to make a chain with carbons. And of course, that's one of the critical aspects of carbon being very useful in living things. And for Earth and space sciences, we're looking at how this carbon dioxide from the atmosphere enters a leaf of a plant and begins to build sugars and starches like cellulose that plant will be built out of. So now, building the chain, we'll remove 1 spring from a carbon, take an adjoining carbon. We now have a chain of 2. We pick up our next CO2 partial molecule, remove one of the springs, slight twist helps, and now we have 3 in a ring. We're going to do this until we have all 6 in a ring. Now I have a chain of carbons. I was saying ring. We're going to make a ring, but right now it's a 6-carbon chain. I'm holding on to this carbon right here. I'm going to call this carbon 1. Count out 2. Count out 3. Count out 4. The 5th carbon. I'm going to look for the oxygen on that 5th carbon, which has an empty hole. And from the spring on carbon 1, we're going to connect things up just like this. So now there are 5 carbons in a ring connected to a 6th atom, which is an oxygen, and we end up with this little tail off the end of a carbon. Now we'll show you how to attach hydrogens and hydroxyl groups, and we'll get back to our water molecules. So now we'll address the water molecules. We're just going to leave the 2 springs on the oxygen. We're going to remove these hydrogens. They each have a place to go. We're going to set down this oxygen atom, and when we come back to our glucose, which we'll get in view here, in our main chain, typically we're going to have a spring that will need a hydrogen. I have some springs left over from my original CO2s. I'll add this to a hydrogen, which will come out of an oxygen from that same carbon. That makes an OH group, usually just written OH, also called a hydroxyl group. You'll continue around, another water molecule, a hydrogen off each, spring to the carbon, put a hydrogen, well, spring left over from CO2 into the hydrogen, make an OH group, H group, OH group, hydrogen, hydroxyl atom coming from water. Continue that all the way around, and then we'll deal with our little tail off the end. So now we'll be filling in this last carbon, the one that hangs off of the 5th carbon, and this is what we have left in terms of water molecules. So we're going to get a spring and a hydrogen, take this lonely oxygen off the tail, and insert a hydrogen on it for our hydroxyl group. We'll remove the hydrogens from our final water molecule. We now have a complete glucose, and we'll get a good shot of what my models look like right now. So a complete glucose, I've used all of my carbons, all of my hydrogens, used all of the oxygens that, remember, came from carbon dioxide, but carbon dioxide lost a few, and hydrogen lost a lot. So, okay, we're good. And now you see these leftover oxygens. And oxygen in nature will bond to itself. And the way to indicate that is you pick up some of your oxygens left over from water that still have the springs, few oxygens that were inherited from CO2 can hook in there, and that is an O2 molecule. And we'll just continue doing that until we've built and used all our oxygens. So this is what we see now. We have a molecular model of glucose, which has the chemical formula of C6H12O6. Funny looking 12. Give it a little space there. Much better. And we have a second product. There are a total of 12 oxygen atoms. They are molecular oxygen, 2 atoms per molecule. So we write that 6O2. So there we are, photosynthesis. 6CO2 and 6H2O ends up with a product of a glucose molecule, C6H12O6, and 6 oxygen molecules. The carbon dioxide that came from the air, the water that came through roots and up into a leaf, into a chloroplast, been combined into a sugar, a more complex molecule, and oxygen is produced in excess and will exit the leaves into the atmosphere. Thank you so much. Have fun with your models. When you clean up, reverse the process. Make sure the kits end up the way they started class, and everybody will be happy.